Hello guys, in today's video we're looking at 2023 Science Paper 1 and we'll be answering from question 1 to question 4. Question 1 read, the following diagram shows a pendulum that moves from A through B to C and back to B in 1.2 seconds. And the question is, what is period of the pendulum? How do we find the period of pendulum? So for solution, we all know that period, it is equals to time divided by number of oscillation. And if you can see from this pendulum here, we have time, and for oscillation we have, because this one moves from A to B to C. So this oscillation, when it moves from A to B to C back to A, that means it is one oscillation. Okay, that's what we call a period. So since it only move from A to B to C and back to B without reaching point A, so that means it is 3 out of 4, because it moves as it reached point A again. That means it will be 4 over 4, which is equals to 1, which is 1 oscillation. Now because it only moved 3 out of 4, so we're going to say period, it is equal to time 1.2 over 3 over 4, okay, in which it will be period equals to 1.2 over, when you divide 3 divided by 4, we're going to have 0.75. Then if you divide 1.2 divided by 0.75, you're going to have t equals to 1.2 divided by 0.75, you're going to have as 1.6. So this is a period here. Okay, let's continue with question 2. And for question 1 we are done. For question 2, we are told a bomb was dropped from a plane that was flying 2.0 kilometers above the ground at a speed of 900 kilometers per hour, and we are told to ignore air resistance. Air resistance is the force which opposes the plane which was flying at that particular direction. Okay, and we have to take gravity, which is G, as 10 meters per second squared. And the main question is, how long did it take the bomb to strike the ground? So we have this plane here. Don't mind my drawing. Okay, this is a plane here. It was going this direction at a speed of 900 kilometers per hour. And the distance from the ground, it is 2.0 kilometers. Okay, and now we are told that there is a gravitational force as this bomb was falling, and the gravitational force was given as 10 meters per second squared. Okay, so now which equation are we going to use for us to find how long did it take the bomb to strike the ground? So in here we asked about the time in which this bomb reached the ground. So first of all, there are some data which you should pick. Not every data here should be picked. Okay, so this one here should be ignored because this is the speed of a plane, but as we are considering the bomb. Okay, so we are going to use this equation as a displacement. It is equals to ut plus half gt squared. Okay, in which our displacement, it is this distance from the ground to reach where the plane was. Okay, and this distance must be converted into meter. How do we convert this one? So we're going to say 2.0 kilo. It is made up of 10, so we are going to say 2.0 times 10 power 3, which is the meter. Where this kilo, we have substituted with 10 power 3, in which it will be 200 meter. Okay, so here we have 200 meter, which will be equals to this bomb started at this velocity here. That means here initial velocity it is 0. Okay, so initial velocity is 0 times t, then plus half of gravity. We are told it is 10, so times 10, and times time, the second time we are not given, which is t squared. Okay, time, how long did it take for this bomb to strike the ground? Okay, so in which we have as 200, which should be equals to 2 into 10, which is 5. So we have 0 times t, which is 0, plus 2 into 10, which is 5. Okay, then times t squared, in which 0 plus 5, you're going to have 0 plus 5 times t squared, you're going to have 5 t squared, which should be equals to 200. Okay, 200 meter, in which when you divide by 5, in which it will be 20, it is 4, so we're going to have 40. Oh, here it is, because 2 times the 1,000, you're going to have 2,000. Here we have 2,000. Okay, so here we're going to have 400 here. Okay, then you provide square root both sides, in which t it will be equals to the square root of 400, it is 20, so it is 20 seconds. So that's a time on which this bomb strike the ground. This is how we find the time. Now let's move on to question 3. Okay, the following diagram shows a uniform 4 meter wooden rod pivoted at its midpoint. 4 forces are acting on the rod to keep it equilibrium. So these are forces, which is 1, 2, 3, and this force which is here. That's what they say. We have 4 forces. Okay, and we are told to find what is force A? Force F. What is this force A? F here. Okay, so how do you find force F? We all know that clockwise it is equals to anti-clockwise moment. Okay, in which here we are going to say, when you take this force here, which is first parameter here. Okay, so first force, we have the force acting downward. So force acting downward, it is, so this distance from here to here, it is 2. Okay, because this all wooden rod, it is 4 meter. So because it is at the middle, so that means from here to here it is 2 meters. So here we have 2 times F, which is the force acting downward. So now 4.2, so we are going to move on to the forces acting downward. So when we talk about the forces acting downward, so let's take, for instance, we have a beam here, there's a force acting here. So that means this wooden will move anti-clockwise, because this force, it is acting at this point here. But for this force, it is acting downwards, so that means this will then move clockwise. Okay, so that's why we are find 2f. Here I've multiplied because this distance from here to here it is 2, so it is f times 2, which is 2f. So the second parameter it is we are going to multiply, because moment it is equals to force times the distance, okay, in which it will be equals to force times distance, which is 20 times the 1.5. Okay, 20 times 1.5 you are going to have as 30 Newton. This is our second force here. Okay, so now let's move on to this force which we have here. And the force, this force here, it is acting downward also. Okay, so we have parameter 3, which is this force. This force, it has a distance of 1.0 meter. So we are going to say moment equals to force times distance. So force we have 30, h times 1.0, which should be equals to 30 here. Okay, 30 Newton. For the last parameter, which is 4, then we are going to take the moment about this point here. Okay, so this point it is acting, the force it is acting at this point. That means there's a distance of 2 meters, because the distance from here to here it is 2 meters. So we're going to say moment equals to force, which is 20, times which is 2, which should be equals to 40. Okay, 40 Newton. If you can see from this given information now, you can find F. How can you find F? Because I've said clockwise moment it is equals to anti-clockwise moment. So clockwise moment we have 2F. So we have 2F, which should be equals to you add these forces, which is 30 plus 30. 30 Newton plus 30 Newton, then plus 40. You add, we are finding the total. We have to balance this pivot for us to find this force here. Okay, so 2F it is equals to 30 plus 30, which is 60 Newton, then plus 40, then 2F it is equals to 60 plus 40, which is 100. Then you divide by 2 by 2, so that means F it is 2 into 100, which is 50. So 50 Newton. So 50 Newton it is here. So 50 Newton it is our force here, which is acting at this F here. Okay, so this is the answer for question 3. Thank you for watching, and don't forget to subscribe and turn on the notification bell so that next time you see the update. See you next time. Bye bye.